Alright, so evaluate without a calculator. What's the first one?
1/3.
1/3. Good.
You worked through that one?
Yes.
That didn't really...
10 to what power equals the cube root of 10? So what power is the cube root?
1/3.
Fraction. What about the next one? It's hard. Negative 1/2. Well, I stand correct. The negative flips and puts it on the bottom, the 1/2 roots. And the last one. Okay, this is properties of logarithms. If you don't have a note card, take a picture. You'll want one. And then if I were you, I would throw that conversion on the note card as well. What does your note card look like? Probably.
It has that on
Looks like that.
Why?
If those are equal, then the numbers on the inside have to be the same. It is obvious, but it is something you'll need to solve logarithmic equations. If you have a log on one side, you can essentially ignore the two logarithms and set the insides equal. Any questions? Everyone got this somewhere? And again, is this on your note card also, the little conversion thing? Here. The conversion thing. It's on your notes from yesterday. Remember the little circle thing? That didn't show the circle things, but okay, write as a single logarithm. So how would I write the first one as a single logarithm? Log base 3 of... Very good. How'd you do that? Then when you're adding, you multiply. What up next?
2 over the power and 3 over and divide.
Y'all remember seeing some of this on your ABC packet?
Yes.
So if you didn't know how to do those, sounds like you remembered a lot. That's nice. And then, how do you know which ones go on the bottom and which ones go on the top? Yes. As will z squared. Here's what you keep in mind. Remember, a logarithm is an exponent, right? Positive exponents go on the top, and negative exponents go on the bottom. So, that's a parallel property of logarithms and exponents. So, log base 2 x cubed z squared over 4 squared.
Oh, I imagine it was every z squared.
Right. Now, how it would be that way is if you had parentheses. You know what I mean by that. So, good rule of thumb is pay attention to the sign, right? Positive. It's actually the sign. questions about how he got there. We went really fast through that last year. This slide probably took you a long time. Any questions about those? Coming back. Expand. The first one, the reason I put that up there is a lot of times people think they can't expand 3 times x because they think they're stuck together. I just wanted you to know that you can do log base 2 of 3 plus log base 2 of x. If you can expand that, those vectors do separate. A 1/2 power. 1/2. The reason this says well, I used to teach algebra 2 as well. I pulled these yet, but we crammed a bunch of A's into one. So really after 2 months. You've probably seen these before at some point. Something that Miss Lowe probably didn't spend a lot of time on and was probably, might have not even made you do, but I want to make you do it. Can I do log base 4 of 2?
I think so.
What is log base 4 of 2?
1/2.
Why is it a half? It's 4 to the 1/2 power equals 2. So this whole thing here is just the number 1/4. I don't know if she made you simplify that there or not. Do you need to know that? Yes. Are you going to have to? Open response? That's fine. To match the multiple choice answer, you may have to simplify. The AP Calculus exam on the open response will accept any unsimplified equivalent answer. So you don't have to simplify on the open response. However, the alternative side to that is they will crazy simplify multiple choice answers. And so sometimes you're trying to match an answer that doesn't look anything like the answer you got. Sometimes they will use trig identities. That's the reason we memorize those. Sometimes they will use properties of logarithms. That's the reason we're memorizing these. And a lot of those things from Algebra 2 come in on multiple choice, on matching multiple choice answers. That's why I make you memorize what I'm making you memorize. Do I need to do any more on this slide? These are just interesting problems that come up sometimes. Sometimes they'll give you log 3, log 4, log 5, and ask you to use properties of logarithms to find other things, like log of 1/25. So how could I use those numbers to help me find log of 1/25? Okay, so how would I break this down into something that would be a log of 5? First of all, wouldn't you agree log of 1 minus log of 25? And then log of 25, can I change that to be 5 instead of 25? Would you agree?
5 times 5.
It's 5 squared, right? Could I do 2 log of 5? What is log of 1?
0?
How do you know it's 0? Anything to the 0 power is 1, right? So log of 1 is just 0. Log of 5 is 0.6990. Let's say without a calculator. Can I multiply that without a calculator? Yes, I can. If you don't think you can, that's how y'all multiply, or y'all do that?
It's 1.39.
It's 80. You do something. Where did the 2 come from? How do we add them from?
Oh, did I add an extra?
Yeah, it's like.
I added an extra. There was no 1. Yeah, because 0 and then 18 carried a 1. I don't care how you do it. If you do lattice, if you do it correctly, thumbs up. Great job. Any questions about that? Positive or negative?
Negative.
Any questions about that? What about log of 20? Okay, log of 4 times 5, but how would I have to write that in single logarithms? Plus log 5. And so we've got 0.6021 plus 0.6990. Again, yes, it's yucky addition. It doesn't mean we can't do it. Don't confuse tedious with I can't. A lot of times I hear calculus students say, I can't add these big numbers. That hurts my feelings. That's 5th grade math. You can. It's been a while. Yes. Can't would not be the correct word for that. I might have to write it down on paper. I might not can do it in my head. It doesn't mean I can't do it. So make sure you don't confuse those two things. What is that answer? 3 what? Any questions about that? This one's probably 5th grade math. That one's probably 3rd, 4th, I don't know.
Fatty.
Just adding numbers together, that's a long time ago.
3rd grade was full. That's what it was.
Right, so that means you learned it just before that. I don't know, I guess with full hair, maybe. Okay, you need to know that this exists. Your calculator has almost made this useless knowledge. Almost. I don't know that the TI-89 has this built in yet. It does. 4 years ago, they updated the operating system on the TI-84, and you have the alpha window log base button. Y'all all know where the alpha window number 5 is. That button made this formula almost useless. Before 4 years ago, that button did not exist. So the only 2 buttons you had on your calculator were natural log and log base 10. And so this was a formula, it's called the change of base formula, to get it to where you could just use those 2 buttons. And I know at this point you probably don't need to know this, but if you ever find yourself in a class where you only have a TI-89 calculator, which may happen in college at some point, because you may ditch this one at some point and just do the TI-89, and that's where this formula would be handy. They may have built it into the TI-89, I don't know. I need to look. I have a set of new TI-89s. I could look. You'll get to use those next year. But how this works, if I want to type log base 2 of 4, I'm going to pick that one because we all know the answer. What is log base 2 of 4? I can type that in my calculator by doing log of 4 over log of 2. The log button on the left, or the natural log button, whichever one you want to use. It doesn't matter what you change it to. You can change it to any base you want. Those 2 used to be the only 2 in the calculator. Does it tell you the answers too? All is well perfect in the world. So that's just the change base formula. This, I have seen it one time on the ACT, where they asked you. It gave you a logarithm and it said this equals what? And I had to change the base answers. So I doubt it'll be on there again, but hey, who knows? So log base 2 of 4. There are a couple ways to memorize it. You could say the base always stays on the bottom. log of the inside over log of the base, or log of the big over log of the little, not numerical value, but bigger number, size. So log of the big over log of the little. When I used to have to teach this, that was some things that I would use. Again, almost irrelevant, but something nice to know. I'm probably not going to do this slide because of the irrelevance of the change of base formula. I will do one. If I wanted to type log base 3 of 35 using only the change of base formula and not the log base button, how would I type it?
Log 3 over log.
This one, log of 2 over log of 15. Right, so easy enough. That's how the change base formula works. If you just needed it, there it is. Probably won't, but okay. Solving logarithmic equations, we probably will not finish this today. We'll do this one slide, and then we'll do more solving logarithms. Yeah, we'll do more solving logarithms, more complicated solving logarithms on Monday. The first one is kind of a strange one. What's the easiest way to solve that?
Circle.
Do this circle thing. Just do a rewrite. And so I get x cubed equals 18. And then you could probably do that in your head from there, or you could cube root both sides. So with a correct understanding of logarithms, that's not too terrible. What about the next one? How do you know it's 6? Good. So this is log base 6 of 9x. Log base 6 of 54. Yes, log base 6 of 9x equals log base 6 of 54. Then 9x has to equal 54. And so x would have to be 6. Gosh. That one could have been on your homework last night. 3, how do you know? 3 to what power equals 27? And the last one. The idea is it's tough.
So we multiply the 10 inside and change to 4x log 6.
Okay, good. First, go ahead and change this to log base 7 of 8x. Does everyone agree?
It's 4.
And I would even go ahead and do that. Okay with how I got that?
Now,
What did I do?
You distributed
The
1/2.
The 1/2 is an exponent, and it goes with both pieces. So I went ahead and said, okay, well that's a square rooted there. If you don't like dealing with the 1/2 power, could you multiply that 1/2 over the other side and make it a square on the 16? You're going to turn out the same because at this point I get the square root of 8x equals 16. What's my first step? Square both sides, right? So you see how that would end up the same way either way? Wherever you put the 1/2. 256. And then divide by 8. 32. Any questions about that? Page 185, 4 through 40 every 4, get number 50. So I think that covers like 3 days of algebra 2 logarithms. We have about 2 days of algebra 2 logarithms left, which means we have 1 day. We will have a little quiz over logarithms on Tuesday. So be ready for a little logarithm quiz on Tuesday. You will need to have the property memorized. You will need to